Believe it or not, you actually weigh less in a certain part of Canada, and not by a tiny amount. For decades, a huge mysterious zone in Hudson Bay has had scientists completely stumped because of its strangely weak gravity. The reason why is an ancient secret that's been buried for 20,000 years, and today we're digging it up. What if I told you there's a place on our planet where the fundamental force keeping our feet on the ground is noticeably weaker? A spot where, if you stood on an incredibly sensitive scale, you would weigh less than anywhere else. This isn't science fiction. This place is real. It's a vast region centered around Hudson Bay, and for more than half a century, it was one of the greatest geological puzzles on Earth. Back in the 1960s, when scientists were first charting the world's gravitational fields, they found something that shouldn't be there, a massive gravity hole. It was as if some giant cosmic hand had reached down, scooped out a chunk of the planet's mass, and left behind an area with bafflingly low gravity. The pull here is about 0.4% weaker than the global average, a tiny number, but one that's monumentally significant. If you were to drop something here, it would actually fall a bit slower than our models predict. For decades, the question was simple: why? What could possibly be powerful enough to erase a piece of Earth's gravity? The investigation would lead scientists down two very different paths, one looking into the frozen past, and the other deep into the fiery heart of the planet itself. To find the first piece of the puzzle, we have to rewind the clock, way back 20,000 years, to the peak of the last ice age. Back then, the area we now call Hudson Bay was completely unrecognizable. It was buried under an unimaginable weight of ice. This was the home of the Laurentide ice sheet, a colossal glacier that covered most of Canada and the northern United States. It's hard to wrap your head around the sheer scale of this thing. In many places, the ice was nearly 2 miles thick. Over Hudson Bay, some parts of the ice sheet were a staggering 2.5 miles high, a vertical wall of ice taller than most mountains on Earth. The weight was astronomical. This wasn't just some snow and ice sitting on the ground. It was a force of nature so immense, it physically pushed the Earth's crust down. Think of it like pressing your thumb into a memory foam mattress. You leave a dent, displacing the material underneath. The Laurentide ice sheet did the exact same thing to the Earth, but on a continental scale. For thousands of years, its crushing weight pushed the rocky crust down, forcing the hot, gooey rock of the mantle below to move aside. The Earth itself was dented. Then, around 10,000 years ago, the climate warmed, the ice age ended, and the Laurentide ice sheet started to melt. Geologically speaking, it happened in the blink of an eye. This colossal weight was suddenly lifted, and just like that memory foam mattress, the Earth started to bounce back. This process is called post-glacial rebound. But here's the catch. The Earth isn't a mattress. It's made of rock, and it rebounds incredibly slowly. Even though the ice disappeared thousands of years ago, the crust is still rising today. We can measure it. Across the Hudson Bay region, the land is still rising by about 12 millimeters, or half an inch, every single year. You can see the evidence in the landscape, with ancient shorelines now sitting hundreds of feet above sea level. It's estimated it could take another 300,000 years for the region to fully recover. So, the first theory was born. The gravity is weaker because the land is still dented. Less mass means less gravitational pull. The rebound hasn't caught up, so there's literally less stuff beneath your feet. For a while, this seemed like the perfect answer. It was elegant, it made sense, and the evidence was right there. But as our measurements got better, a problem popped up. The slow rebound of the crust could only account for about half of the missing gravity. At best, something else had to be going on. The ghost of the Ice Age was only part of the story. The other culprit was far more mysterious and was happening much, much deeper. If a giant dent in the planet wasn't the full explanation, scientists needed another force powerful enough to reduce the mass of an entire region. So they turned their attention from the surface to Earth's engine room, the mantle. The mantle is the 1,800-mile thick layer of scorching hot semi-molten rock that churns slowly between the crust and the core. While we think of the ground as solid, the mantle is in constant, sluggish motion, like a pot of water on a stove, but playing out in ultra-slow motion over millions of years. Hotter, less dense rock from deep within the mantle gradually rises. As it nears the crust, it cools, gets denser, and sinks back down. This perpetual, circular movement is called mantle convection. These currents are the driving force behind plate tectonics. They move continents, build mountains, and open up oceans. In a very real sense, they are the planet's heartbeat. And, as it turns out, Hudson Bay sits in a very special spot. Deep beneath this part of Canada, a river of mantle rock is sinking, flowing downward into the planetary abyss. For millions of years, this downward flowing current has been acting like a cosmic anchor, dragging the continental plate above it down. This pull effectively thins the crust from below, reducing its overall mass. So now scientists had a second, completely different theory. The gravity anomaly wasn't just a scar from the Ice Age. It was an active, ongoing process driven by the Earth's fiery interior. A relentless downward tug from the mantle was pulling mass away from the region, weakening its gravitational grip. For years, the scientific community was split. Was it the ice, or was it the mantle? The two theories were in direct competition, each with strong evidence. One looked to the past, the other to the present. One was a story of weight removed from above, the other of mass being pulled from below. It was a geological whodunit, and the mystery of Hudson Bay's missing gravity remained unsolved. So we've got two incredible forces at play. A scar left by an ancient ice age and a relentless current in the Earth's molten heart. Which one is the real culprit? Before we reveal the shocking discovery that finally solved the puzzle, if you're enjoying this journey into Earth's hidden secrets, make sure to hit that subscribe button and ring the bell. You won't want to miss where we go next. The breakthrough that finally cracked the case didn't come from a geologist's hammer or a deep earth drill. It came from space. In 2002, NASA and the German Aerospace Center launched one of the most remarkable missions in Earth science history, the Gravity Recovery and Climate Experiment, or GRACE. GRACE wasn't just one satellite, but a pair of twins chasing each other in the same orbit around Earth. The science behind it is both simple and genius. The two satellites were linked by a hyper-precise microwave system that could measure the distance between them to within a micron less than the width of a human hair. As the lead satellite flew over an area with slightly stronger gravity, it would be pulled forward, increasing the distance to its twin. A few seconds later, the second satellite would pass over the same spot and get pulled forward, closing the gap. But when the satellites flew over a region with weaker gravity, like Hudson Bay, the lead satellite would speed up less, causing the distance between them to temporarily shrink. By meticulously tracking these tiny changes, the GRACE satellites created the most detailed map of Earth's gravity ever made. For the first time, scientists could see all the lumps and bumps in Earth's gravity with stunning clarity. And when they pointed GRACE at Hudson Bay, the mystery finally began to unravel. The data was so precise it allowed researchers to build a complete model of the region's gravitational signal. And here's the brilliant part. They calculated the exact gravitational effect that the post-glacial rebound should be having. They knew how fast the land was rising and could model the gravity signature produced by that process alone. Then, they subtracted that rebound signal from the total gravity signal measured by GRACE. Whatever was left over could only be from the deeper geological processes. The result was the aha moment scientists had been waiting for. It wasn't one theory or the other, it was both. The GRACE data confirmed with astonishing accuracy that the two processes were working together. The numbers showed that the slow, ongoing rebound from the Laurentide ice sheet was responsible for about 25 to 45% of the missing gravity. The bigger player, though, was the mantle. The data revealed that the downward pull from mantle convection was responsible for the majority of the effect, somewhere between 55 and 75% of the total anomaly. The ancient ghost of the Ice Age and the slow boil of the Earth's interior were co-conspirators. The case was closed. So, the spot on Earth where gravity is strangely weak is no longer a mystery. It's the result of a perfect geological storm, a 1-2 punch delivered over vastly different timescales. First, the immense weight of a 2-mile thick ice sheet squashed the crust 20,000 years ago, leaving a dent that is still slowly healing. And second, a relentless downward current in the Earth's mantle, a process happening for millions of years, is continually pulling the crust down from below. This discovery does more than just solve a local puzzle. It gives us a window into the very nature of our planet. It confirms that Earth is not a static, solid ball of rock, but a dynamic, living system. The effects of an ice age that ended 10,000 years ago are still measurably shaping our world. The slow, invisible dance of magma deep within the mantle has tangible effects on the surface we live on. And while Hudson Bay is famous, it isn't entirely unique. Earth's gravity is lumpy, with other anomalies scattered across the globe, all telling their own geological stories. It means that yes, you really do weigh a tiny bit less in Hudson Bay. The difference is imperceptible, but it's a real, measurable effect of these two colossal forces. It's a beautiful reminder that our planet is constantly in motion, its surface still responding to the deep past, and its interior still churning with a fiery energy. There are ancient secrets buried all around us, and sometimes you just need a detective in the sky to help you find them. Thanks for watching. If you want to explore another of Earth's incredible mysteries, click on the video on your screen now.